All right, guys, ready. All right, guys. We started with this paper yesterday. Started late because we had some technical issues, technical uh, problems. But we managed to do from question 10 down to here, working backwards. From question 11. So we did 11, 10, 9, 8, and 7. So we did 5 questions. So I'll do these 6 questions that remains, and hopefully we can also do 3 of the questions in the second paper that I said. All right, that's the idea. So send the paper for you to do. You have to do the papers so that when I'm going through it now, you're seeing the mistakes, you're learning from the mistakes. It's a state where you have to do the questions and send them. All right. So this question says scale of a map is 1 to 25,000. I'm going to do a class where I deal with maps and scales and racial proportion specifically. All right. Maybe after the third, I might do that. All right. But I'll just go through this question and explain it just to see. So this is the scale of a map. 1 to 25,000. For example, it means that 1 centimeter on the map would be 25,000 centimeters on land. That's what it means. Map is going to be in centimeters, that's small space. On the land, it's going to be in meters or kilometers. So what you want to do, you would want to convert this 25,000 centimeters to meters by divided by 100, or then you get it to in meters, you divide it now by 1,000 to get it in kilometers. So from this scale, if the question is asking for measurements in meters and centimeters, then you want to establish from this scale from the get-go that it really means that 1 centimeter on the map is 25,000 centimeters on land. And they want to convert this 25,000 centimeters. So it will be 1 centimeter on the map divided by 100. It will be 250 meters because 100 centimeters make a meter. And then if you want to get it in kilometers, you then divide this by 1,000 because 1,000 meters is a kilometer. So if you want it in kilometers, it will be 1 centimeter on the map divided by 1,000 with 0.25 kilometers on the land. That is for distance. This is the scale for distance. That's for distance. That's a scale for converted distance. Now, watch me now. Sometimes a question will extend and ask you for area. They will ask you for area. So to convert distance scale to area scale, you square the scale. That's all you have to do. Square the scale. Because if you think of an area on a map like this, 1 centimeter by 1 centimeter on the map, 1 centimeter by 1 centimeter on the map becomes on the land 0.25 kilometers by 0.25 kilometers. So if we want to work out this area, we multiply the 0.25 by the 0.25 in actual on the actual land. While on the map, it will be 1 centimeter by 1 centimeter. And so to get the area scale from the distance scale, all you have to do is square the area scale. That's all you have to do if you're going to answer questions in area. So from this distance scale, I want to get the area scale. That is the distance scale. They will always give you the scale for distance. This is the scale for area. This is the area scale. If you want to do some work in area, then this is the scale. You square this. Square these values. So it will be 1 centimeter squared to, you square this. 25,000 squared centimeters squared. If it's this one in meters, then it's 1 centimeter squared on the map, and then you square this again. is 250 squared meters squared. And if it's kilometers you're working in, it will be 1 centimeter squared represents 0.25 squared kilometers squared if you're working in area. You go from distance to area, distance scale to area scale, you square the values. Square the values on the scale, on the distance scale. That's all you have to do. You get the area scale. Square the distance values. You get the area values. All you have to do. So if you're doing a calculation in area, means that 1 centimeter squared on the map, which will be 25,000 squared centimeters squared on the land. All right? That's all you have to do. Well, that's what it says now. It says Underlin and Jersey are 31 centimeters apart on the map. So on the map, that's the distance between them, 31 centimeters. Determined in kilometers, say they want it in kilometers. So since I want the answer in kilometers, we're going to be working with this scale. Work with the kilometer scale. Right? That's what they're going to be working with, the kilometer scale. And that's all I have to do. All right? But I want the distance in kilometers. So work with the one that gives you centimeters, kilometers. So it is 1 centimeter represents 0.25 kilometers. You want to know what 31.8 kilometers is? You just multiply the scale by 31.8. And so you multiply this by 31.8 to get 31.8 centimeters. It's equivalent to 0.25 times same 31.8 kilometers. Whatever this works out to know is your answer. Kilometers. Simple as that. But understand that? Let me see if I can get my calculator up here. Hold on. This is it. So I need to split the screen. Perfect. Hold on, guys. Hold on. Trying to get the calculator. Let's try. I don't know why I'm putting that on this side. But anyway, let's work with it. All right. So you want, let's use the calculator and do this calculation. So it is 0.25 times 31.8. That is 7.95 kilometers. That's the answer. That's the distance right here. All right? That's the answer right here. Next part now says the actual distance between Clifton and Jamestown is 2.75 kilometers. How many units apart are there on the map? In other words, what is the distance between them and them? We're going to work with this scale again. Work with this scale again. So look at it. Start with that scale again. So if you're working from it, you're going to turn the scale the other way around. And you're going to say, all right, 0.25 kilometers on the land is equivalent to 1 centimeter on the map. This is on land. 0.25 kilometers is 1 centimeter. So you want this 0.25 to become 2.75. And with multiple ways. Again, so what number do I multiply this by for it to become 2.75? By dividing. Or I can divide it by the 0.25 first to get it down to 1 and then multiply it back up to the 2.75. Understand that? Good? So I can bring it down to 1 because when you're doing maps and scale and ratio, all you need to be doing to do your calculation is multiplying and dividing by a value. It's not more than that. So I want this side to become 2.75. So to make it become 2.75, I can do two things. I can divide it by 0.25 first. But I've divided this side by 0.25 as well. Then after I do that, I really want it to become 2.75. So I'm going to show what it is now. So it is now 1 kilometer. It's 1 divided by 0.25. I think that is 4. 1 divided by 0.25. Yeah, that is 4. That is 4 centimeter on the map. And I really want this to become 2.75. What do I do next? I know multiply by 2.75. But this now becomes 2.75 that I want it to be. And this now is 4 times 2.75. So it becomes 2.75 times 4. This is now 9.8 centimeters on the map. That's the answer right here. So maps, ratio, maps and scales and ratio and proportion, those questions can be done simple by multiplying and dividing by values to get the information that you want. Simple as that. All right? Simple as that. But good? But all right? That is it. All right? I'd advise you to go and redo the question. All right? We're going to do this topic proper on Thursday. Spend some more time on it. Huh? Okay? Multiply the 4 because I'm multiplying the ratio now by 2.75 because I want the kilometer side to become 2.75. So I multiply the whole ratio by 2.75. So when this part becomes 2.75, I know what this side is. So I'm basically multiplying the 4 by 2.75. It's over here on the screen. Oh, it's 2.45 I put. Oh, that's a mistake. It's 2.75. It should be 2.45. Not 75. 2.75. So the answer is actually 11. My mistake. 2.75 I have to multiply by. But that's a typo. So that's 11. It's actually 11. Actually 11 centimeters. I'm supposed to multiply this by 2.75. Get the 11. But good? All right. That's it. Thanks for picking that up. Our next question. It's a circle and measures question. But it's circles, length of arc, here of circle, here of sector, stuff, stone. This one said the diagram below shows a square ABCD drawn inside a circle. The vertices of the square lie on the circumference. All right, so this is a square now, so you know that all 4 sides are equal on that square, and the angles are all 90 degrees. 90 degrees, 90 degrees, right? It says the length of a side of a square is 11 centimeters. So each of these sides is 11 centimeters. Put them on in red. This is 11 centimeters, 11 centimeters, 11 centimeters, and this side is also 11 centimeters. Question says, show that the diameter is this. 11 times the square root of 2. All we have to do is work in this right angle triangle. This is the diameter, you know. What is Pythagoras theorem in this triangle? See that? That's hypotenuse. So the diameter is hypotenuse, right? So in triangle ABC, it's a right angle triangle. The diameter is AB, is AC. AC becomes equal to the square root of 11 squared plus 11 squared. Square root of this side squared plus this side squared. But understand that? Right? 11 squared plus 11 squared. So it becomes square root of 2 times 11 squared. 2 of them. Which then becomes square root of the 2 times the square root of the 11 squared. Square root of 11 squared is 11. Understand that? So it becomes the square root of 2 times 11. That square root of 11 squared is 11. And so that's what it becomes. This 11 times the square root of 2. 11 times the square root of 2. So that's 11 times the square root of 2 centimeters. Yes? Huh? Explain it again from the beginning. All right. So you understand that we're using Pythagoras' theorem? Because I write on my triangle, right? And the 2 sides in there is 11 and 11. So Pythagoras' theorem says that the hypotenuse squared, write it out. AC squared will be equal to AB squared plus BC squared. Right? The AB is 11 squared, and the BC is also 11 squared. The BC is also 11. So that's AC squared. So if you want to find AC, you have to square root both sides. And so AC is now the square root of 11 squared plus 11 squared. Understand that? So that starts with it down here. So that's the square root of 11 squared plus 11 squared. 11 squared. So it's 211 this, all right? So become the square root of 2 times 11 squared. Understand that? All right, suppose this was the square root of A plus A. Wouldn't that be the square root of 2A? All right, so let's change this A to 11 squared. And this will become 11 squared too. See now? It's two of them. It's 2 11 squared that we're adding. So it's two of them. 11 squared plus 11 squared is 2 times 11 squared, right? Good. Then now, what maybe you don't know is that if you have the square root of a product, A times B, it's the same as the square root of A times the square root of B. Square root of a product, the square root of the product each other. And multiply them just the same. Square root of AB, square root of A times the square root of B. And that's all I'm doing. I'm splitting this up. Right? So I'm treating this like one value like a A and treating the 11 squared as a B. I'm splitting this up. Right? So this becomes equal to the square root of 2 and the square root of 11 squared. Understand that? But the square root of 11 squared, like the square root cancel the square. So this then becomes the square root of 2 times 11. That becomes 11. Square root of 11 squared becomes 11. So it's times 11. Square root of 2 times 11 is the same as 11 times the square root of 2. Right? I just turn them around, switch them around. Better? Better? Right, and that is in centimeters. That's it. Body good? Body good? All right, next question. It said, no, calculate the area of the circle. Oh, remember what we have there is the diameter. So the diameter is 2 times the square root of 11 centimeters. Then it means that the radius is half of that, don't it? That's all? Radius is half of this. Half of 2 root 11 is just root 11 centimeters, square root of 11 centimeters. But I get that. The diameter is 2 times square root of 11, then the radius is half of that, square root of 11. We're using that now. Area of a circle is what? Pi r squared, don't it? Pi r squared. That becomes, did they tell us to use for pi? Did they tell us what to use for pi? When I don't tell what to use for pi, is it calculator pi here? Okay, it's 3.14. Did they tell us what to use for pi? No. So when they don't tell you what to use for pi, you can use the pi on the calculator. This becomes pi times the square root of 11 squared. The r squared becomes the square root of 11 squared. Square root of 11 squared is 11, so it becomes 11 times pi. And you can work this out with the calculator. So I wanted to do that to my places. So I want to work that out with the calculator. So I'm going to do 11 times the square root. Pi times 11. The theta now is pi times 11. 2 centimeters. That's 34.56 to 2 centimeters. 34.56 centimeters squared is the area. Then I want the area of the square. The area of the square, just 11 times 11, don't it? So remember the size of the square? It's 11 by 11 square, right? So you have the square just 11 by 11. So let's write AC. You write it. You have the circle. You have the circle. You have the circle. You have the circle. Then one area of the square. Area of the square is 11 times 11, which is what? 121. 121. Something wrong with this. Something is wrong. You have a circle. The square not supposed to be bigger than the circle. Something around 5 times 11. 3.14. Something is wrong. Pi squared. So something is wrong. So the diameter is, each side is 11. Forget the diameter as, 11 root 2. I wrote the wrong thing. It's not 2 root 11. It's 11 root 2. It's 11 root 2. My mistake. It's 11 root 2. This is 11 times the square root of 2. So the radius becomes half of that. The radius becomes half of that. 11 times the square root of 2 over 2. Half of that. All right, so let's recalculate this. It's here and all right. So we're squaring this now, guys. I'll square this. So we're squaring 11 root 2 over 2. That's the radius. So squaring that. Okay, I'll just put it in the calculator and see what we get. All right, so it's 5 times. I work it out to relax. 5 times bracket fraction 11 times the square root of 2 over 2 close bracket squared. Okay, 190. So it's 190.07 centimeters squared. That's a better answer. Someone's clearly wrong a while ago. All right, so that's the area of the whole circle. Then the area of the square now is this. 11 times 11, 121. The area of the square is 121. All right? Look at this now. They want the area shaded. They want the area shaded now, guys. So look at the diagram and tell me we're going to get area shaded. We have the area of the square is 121. We have the area of the circle is 190.07. Another one, the area shaded. Look at it. We're going to find the area shaded. Huh? Look at it. How would we get the area? We know the whole area of everything. We also know the area of the square inside here. How can we get the area shaded over here, sir? Use what we have. We have the area of the whole circle and we have the area of the square. I want this area right here, sir. We subtract the area of the circle and the square. I'll get the whole of the area on us. Divided by 4. Right? Divided by 4. When I subtract the area of the square from the area of the circle, I'm getting all of the area around here. So if I take the whole area of the circle and I subtract the square, I'm going to have all of this area. The only one of it out of the 4 pieces. You see? So the area shaded becomes the area of the circle minus the area of the square divided by 4. But understand that? Simple as that. So the area shaded equals area of the square, the area of the circle, minus area of the square divided by 4. So the area of the circle is 190.07. Area of the square is 121 divided by 4. And that gives us the area shaded. So the fraction 190.07 minus 121 divided by 4. That's for the 4. We get 17.27 centimeters squared. Let's stick with the two decimal places that they spoke about up here. All right, that is it. But okay, so just go and rewrite the question. I'll do it over again. When I share the video, go watch over the video and do it over again. All right, so that is number 6. Let's go on to number 5. Number 5. Number 5 says, triangle PQR and STR are similar. They are similar because this line across here is parallel to this line out here. So the two similar triangles, therefore, are this one and the big one. What do we know about similar triangles? The ratio of corresponding sides are equal. The ratio of corresponding sides are equal. Now, if you want, you can pull out the two triangles so you have them separately to look at. So you can pull out the small one, for example. And pull out the large one. So you can see the corresponding side that you're working with. All right? This one is RSP. This one is RPQ. So this side corresponds to this side. This side corresponds to this side. And this side corresponds to that side. The ratio of corresponding sides, the two triangles are equal. Ratio equal. All right? It says, complete the following statements. In the diagram above, the corresponding angle PQR, that's this angle down here. Let's call it theta, angle PQR. And the STR, that's this one over here, the same one, are what? What's the relationship between them? Corresponding angles are equal. In similar triangles, corresponding angles are equal. So the corresponding angles are equal. And the something of their corresponding sides are the same. They're what? Ratio. The ratio. So in similar triangles, the corresponding angles are equal. The ratio of corresponding sides are equal. The ratio of the sides are equal. All right? So this is testing your knowledge of that. Similar triangles, while the sides might be different, the angles are the same. You have the same three corresponding angles. All right? To do the exam, you have to know what you need to do. Question says, in the diagram above, not draw the scale. RS is 50. Let's put them on the diagram. RS is 50. Where's RS? Right here says 50. All right. SP. SP is 9. All right. So here says 15. Let's put it on. Here says 15. Here says 9. So the total length here says how much? So we can put on this one. What is that total length? 9 and 15 is how much? 24. So this is 24. Agreed? So 15 corresponds to 24 right now. What is that? Good. And then it says no, ST is 12. That's this side across here. It's 12. So this is 12. Is that this is 12. Remember now, this side corresponds to this side, right? But good. It says determine the length of PQ. They're asking us for this side now, PQ. Let's call it X. Let's call it X. Ratio of corresponding sides are equal. So we can say, for example, this X over the 24 will be equal to 12 over the 50. You understand that? The ratio of the sides are equal. You can set up an equation like that. Because the ratio of the corresponding sides are equal, you can say X over 24 on the big triangle equals 12 over 15 on the smaller triangle. You understand that? All right? And then you just take the 24 and multiply it up here to find the X. So the X will be equal to, you call it the PQX. X will be equal to 12 over 15 times the 24. You multiply the 24 PS. And it's work that out and you get that distance X. It's 12 over 15 times 24. That's 19.2 centimeter. That's it. Ratio of corresponding sides are equal. Anything else? All right, so that question done, right? Simple as that. Ratio of corresponding sides are equal. Next question. It's a transformation question. It says, the graph below shows triangle DEF and its image D prime, E prime, F prime after a transformation. So the transformation is from this one to this one. Now they're going to ask you to describe the transformation for sure. All right. First, I want to state the coordinates of the point E right here. What's coordinates of the point E? Look at the scale carefully. So this is 1, here will be 2, 3, here will be 4. So this point is 4, 2. But I agree with that? So E is the point 4, 2. What else I want? It says describe fully the transformation which maps DEF onto D prime, E prime, F prime. Let's look at it. From this to this one. Now they look at it, because a process of there's a process of elimination if you want. But as I look at this, I can see it's a rotation. All right? All right. Let's eliminate. It's not a translation. Because a translation, the image and the object would look the same, right? Same in every just in a different position. It's not an enlargement, but the two of them have the same size. So it's either a rotation or a reflection. So to decipher that it is not a reflection, or decipher if it is a reflection or not, you can check the orientation. If the orientation is not reversed, then it's not a reflection. A reflection in a line reverses orientation. So EFG for this one is this way, anticlockwise. And EFG on this one is also anticlockwise. So you know it's not a reflection, it has to be a rotation, only rotation length. So if it's a rotation, you need to know 3 things. You need to know the angle of the rotation, the direction of the rotation, and the center of the rotation. All right? Now the angle of the rotation is clearly 90 degrees. I want to know. Because this piece, for example, that was horizontal, DE has gone vertical, like that. So turn up this way. You can see that by 90 degrees. From horizontal to vertical, that's a 90-degree rotation. So you know the angle of rotation is 90 degrees. So you're done with one thing. You also know the angle of the direction of rotation is anticlockwise, because this arrowhead was pointing this way, is now pointing up that way. See that? That's anticlockwise rotation. So you have 2 things for the rotation. So it's 90 and it's anticlockwise. The next thing you need to find is the center of the rotation. Now, most times, the center of the rotation is the origin. So I always say to the student, check if it's origin first. Check if it's origin first. Now, how you check the origin? You can check if the coordinates to a point, if you rotate the coordinates like a L that will take you to the coordinate, rotate it anticlockwise 90 degrees as well. So from here to E, for example, it will be this line and this line. If I take that red L and I rotate it up 90 degrees, this piece that is on the x-axis would come up to here, 4 units. And this piece at the top of it would come over here. See that? But that's not. So the coordinates will take me from E to E prime. And let's test on another point. Let's test the same thing on D. So D, the coordinates to D will be 1 across here and 2 up there. About here. So imagine you take this L-looking thing and rotate it anticlockwise 90 degrees. This horizontal piece will come up here, 1 unit, and this 2 units at the top of it will come across here, 2 units. So you see it will rotate D to D prime. So you say yes. Right? So it means that yes, center of rotation is right here. So that's a quick way to test if the center of rotation is actually correct. Right? If you like, you can also just draw lines. So if you draw a line from E to E prime, and then draw a line from the O to E, sorry, and then O to E prime, and see that the angle inside is 90 degrees per real. See that? So the rotation is 90 degrees over there. And you can do another point. So draw a line from O to D, and draw a line from O to D prime. And again, you see that this angle is 90 degrees. See there, this rotate to that. See that? So you can do that sort of stuff. You want to do it for F, same thing. Draw a line from the center of the rotation of the F. Say like you rotate this line 90 degrees, would it come over to here? Over to F prime. You there? That's another 90 degrees. If you rotate this point 90 degrees, it will go down to there. So that again is confirming that the center of the rotation is the origin, right here. So we know the direction is anti-clockwise, the angle is 90, and the center is the origin. So then you write that. If you're describing a rotation, you must give those three things. All right? So this is a 90 degrees anti-clockwise rotation about the origin. Oh, remind me of something. Anti-clockwise rotation is positive or negative. So instead of saying an anti-clockwise 90 degree rotation, the anti-clockwise rotation is negative or positive. Anti-clockwise rotation is negative or positive. Anti-clockwise rotation is positive. You have to remember that. You can think of it this way. Remember, in your XY coordinates, up here, so the positive coordinate. That's where the X and Y values are positive. So if you rotate this way, you're ending up in that quadrant here. That's a positive quadrant. The first quadrant is the positive quadrant. So imagine if you take your x-axis and rotate it, you'll be going in the positive direction. You understand that? So anti-clockwise rotation is positive rotation. So instead of saying 90 degrees anti-clockwise, you could have said positive 90 degrees. Positive 90 degrees rotation. Because anti-clockwise rotation is positive rotation. You have to know that, them ask question about that in CSEC sometimes. They will give you a diagram, for example, and ask you, what is the rotation? And give you 90 degrees negative and 90 degrees positive. In other words, they give you a positive 90 degrees and negative 90 degrees. You have to know which one it is. So you have to remember that the anti-clockwise one is the negative, is the positive one. Clockwise is negative. Yes, clockwise rotation is negative rotation. Anti-clockwise rotation is positive rotation. All right, so that is it. Next question. It says, on the grid above, draw a triangle D prime, E prime, F prime. The reflection of triangle DEF. Oh, sorry, the double prime one we must draw. Reflection of the prime one in the x-axis. So we must reflect it in the x-axis. So we're going to reflect this triangle in the x-axis. That's this one. Reflecting it in this line, this x-axis. But we do a reflection with 1 point at a time. Image distance equals object distance. So D, for example, is 1 unit to the mirror line. It's going to go 1 unit on the other side. So it's coming to here. That's where D double prime would be. Then E is 1 unit to mirror line. It's coming 1 unit on the other side to here. That's where F double prime would be. Then this one is 1, 2, 3, 4 units to the mirror line. It's going to go 1, 2, 3, 4 units to the other side to here. That's where E is going, E double prime. And then just draw a triangle. And that is it. That's the image. What good? All right, come on, make sure we get these things right. Then exam. And that question is over. That question is done. All right, so I told you to skip over number 3. This was number 5. Oh, we have number 4 now. Number 4. Functions and corner geometry. All right, number 4. And number 4 gives us this function f of x. And it gives us g of x. All right, and it wants us to find g of 0 plus g of 5. So remember, you're putting those in the g function, right? This becomes equal to the g of 0 first. You're going to put 0 in there for the x. It's going to become 3 times 0 plus 1 over 2 plus. We're doing g of 5 now, which is to put 5 in there now. Put 5 inside here, so now. That's going to become 3 times 5 plus 1 over the same 2. Come on, the denominator of 2, so we can add up the numerator. This numerator is a 1, right? And this numerator is a 16, don't it? Again, 1 plus 16 is 17 again. That's 17 over 2. That's the answer. But all right, nice and easy. Next question. G of f of 5. F of g of 5. Do you just calculate g of 5? G of 5 is this enough. Well, no matter, we can work it out against it. The g of 5 part is how much? 16 over 2, which is 8, don't it? But I can say that from here, g of 5 is 16 over 2, which is 8. We do have to work it out again. G of 5 is 8. All right? So down here now, we want to find f of g of 5. It's the same as f of 8. Why? That's since the g of 5 is 8. But understand that? The g of 5 here is 8. So we calculate it now f of 8. So f of 8 now means we're going to put 8 in the f function. We're going to put 8 right up in here, so now, in the f function. All right? So it becomes 4 times 8 minus 7. Becomes 4 times 8 minus 7. What I work out to? 32 minus 7 is how much? What I get? What I get? 25? The answer is 25. But good. And that's how we can replace the g of 5 with the 8, right? But understand that? Good? All right, next question. F to the minus 1 of 1. 1 f to the minus 1 of 1. Okay, sir? F to the minus 1 of 1. We can find f to the minus 1 of 1. We can find f to the minus 1 of x first, and then put a 1 in it. I think most people will do it that way, right? So for this one, I'm going to find f to the minus 1 of x first. Then we'll do f to the minus 1 of the 1. That's what we're going to do, right? So we're going to start with f equal. What was f again? F was 4x minus 7, right? F is 4x minus 7. I'm going to inverse it. Inverse it. And the x becomes 4 times f to the minus 1 minus 7. Or inverse it, right? You want to make this a subject now. Take this negative 7 and bring it over here first. It becomes x plus 7. And we'll take this 4 and divide it under. Over 4. That is f to the minus 1. That's actually f to the minus 1 of x. So f to the minus 1 of x is this. So therefore, f to the minus 1 of 1 means they're going to put 1 in here. Therefore, f to the minus 1 of 1 means they're going to put 1 inside here. So now, it's going to become 1 plus 7 over 4. 1 plus 7 is 8. That's 8 over 4 is 2. So the answer is 2. But good? All right. Next question. They give us those 2 points. And it wants us to find the gradient first. So my gradient is difference in y over difference in x. The direction you go when you take the difference in y, you must take the same direction for the difference in x. Because gradient is a measure of direction. You have to take the direction into consideration, right? So gradient of PQ, let's call it small m PQ. Equals, you can, for example, let's say we're doing this point minus this point. We can say, for example, yq minus yp over xq minus xp. The yq is 7. The yp is -1. So it's 7 minus -1. That becomes a plus. xq is 2 minus xp is 6. But I say that this then becomes, that gradient of PQ becomes at a positive 8 because it's minus is a plus. Becomes an 8 over 2 minus 6 is -4. 8 divided by -4 becomes -2. 8 divided by -4 becomes -2, yes? No, it don't matter the order. You have to be consistent with the direction. So for example, if I were to do it over, I could have gone YP minus YQ. I have to put now XP minus XQ. Correct? And so up here, you will get minus 1 minus 7. Because YP would be minus 1 minus 7. 7 will be YQ. That's what you would have. And under here now, you would have XP, which is 6, minus XQ is 2. You would now get negative 8 over 4, which will still give you a negative 2. So this is all, we could do it that way. You just have to stay consistent with the direction that you subtract the value. But understand that. All right? That is it. Next one. The coordinate of the midpoint. Remember, the midpoint like an average point, right? The midpoint is an average point. So the coordinates again, write them down. E is 6, negative 1. Q is 2, 7. So the midpoint. Let's call it capital M. Remember, the average of the X values and average of the Y values, like an average point. The midpoint like an average point. Simple as that. So add the X values divided by 2, add the Y values divided by 2. Finding the values in the middle. All right? So it becomes average these two X values first. That's 6 and 2. You average them. And you average these two Y values. That's negative 1 and 7. You average them. Midpoints are average point. 8 over 2 is 4. This is 7 minus 1 is 6. 6 over 2 is 3. So the midpoint is 4, 3. All right? Then I want the equation of the perpendicular bisector of PQ. The perpendicular bisector of PQ, the one is. What's perpendicular bisector? Let's remind ourselves. So it's like we have the line PQ. Let me see. Let me put the relative position. 6, negative 1, 2, 7. All right. So it's like you have this line, PQ line. All right? And then you have the midpoint right in the middle here between them. The perpendicular bisector, the line that is perpendicular to it, perpendicular bisector. And also passes to the midpoint. It cuts it in half. That bisector, it cuts it in half. So this line we want. That's your perpendicular bisector. Right? That's your bisector. Let's call that line 2. The perpendicular bisector is line 2. So to find the case of that red perpendicular bisector, we need to know 2 things about it. We need to know the gradient and a point. But the point already, the point is M. But the passes through the midpoint M. This point. And put the perpendicular on the other side over here. This point is M. 4, 3. So the midpoint already. Point at the passes through. Next thing we need is the gradient. It is perpendicular to the blue line. So it have a negative reciprocal gradient of the blue line. So you see there now, the gradient of line 2, the perpendicular bisector, is minus 1 over the gradient of PQ. Remember the gradient of PQ was this negative 2 here, so? So I can put negative 2 under here. Or you can flip the negative 2 and change the sign. So it becomes negative 1 over negative 2. The negatives cancel, you get a half. So you're going to have the red line is a half. If you flip negative 2 and change the sign, you're going to get a half same way. But understand that. We're going to have the red line is a half. So we're now using this gradient and this point to get the equation. Some people use the method of using y plus mx plus c and use a point to calculate c, but we can use the BFF formula. So the equation of a line becomes, using the BFF, y minus the y1 at the midpoint equals the gradient of line 2 into x minus the x value at the midpoint. That's the BFF formula to do it. Put the values in there, get the equation straight. So it's y minus the y value at the midpoint is 3. It's 3 right here. The gradient is a half into x minus the x value at the midpoint is this 4. Let's see that. So it's y minus 3 equals, because this half times this 4 is a whole number, I'm going to multiply the half through this bracket. So half of x is half x. Half of the negative 4 is negative 2. Then this 3 comes over, becomes a positive 3. 3 minus 2 is 1. So it becomes y equals half x plus 1. That's the answer right there for that perpendicular red bisector. Red perpendicular bisector of the line P. But good? Anything, guys? You want to work it over if you're not sure. Do over the questions. You have to get familiar with these things. These are things that they ask all the time. They're not difficult. Just if you go and practice it, actually do it. Watching me do it is not enough. You have to go and do it on your own. You see me do it, you go and do it over by yourself. You have a video to assist you. If you don't remember something, go back at it. These are things we have done before, you know. I'm sure we all this part of the question already, you know. Right? But we have to remember, to revise and review, go back over stuff. All right, that's what it's about. All right, next question. Oh, this question done. So we're going to number 3 now. Remember, now I'm going to do 3 questions on the next paper that I sent. At least 3 or 4 questions. The next paper that I sent yesterday. Because yesterday we started very late. That's why I never did finish it. In fact, if we can finish it today, that will be good. You can fly through it, you know. Lazy. Watch our face. Lazy. Come on, we can't lazy in this thing. My exam on the corner, man. All right, so skipping over number 3. I don't do this topic here. I want to do these topics soon. On geometry construction and sets, right? Sets don't come on paper 2 anymore, but it's all over the paper 1. They're both 5 to 7 sets questions on paper 1, eh? Venn diagram, everything in set. Get on question. All right. Number 2. Let's go. They want us to write this as a single fraction. Adding 2 fractions. When you're adding fractions, guys, you want them to be related. You want the denominators to be the same. Related fractions are fractions where the denominators are the same. Right? So in order to get these 2 fractions to have the same denominator, 1 is 3 and 1 is 4, I can get this denominator multiplied up here and down here, and take this denominator and multiply it up here and down here. Then the 2 denominators become 12. So like I'm multiplying this fraction by 3 over 3. Let me multiply by 1. Multiply this fraction by 4 over 4. So let me multiply by 1. Because that way, you know, the 2 denominators become 12. When the fractions are related, they cannot add the numerator. All right? So ready now. So multiply this 4 up here, so now. So it's 4 times 2x is 8x. 4 times this 3 is 12. 12, Mr. Short, 12. Over this 4 times 3 here is 12 as well. Plus, that's this plus in here. I'm using this 3 times this numerator now. 3 times this x is 3x. 3 times this negative 4 is negative 12. Over this 3 times 4 here is also 12. Now that they have the same denominator of 12, you're gonna get that. Just add the numerator, add the values and the numerator algebraically. So it's 8x plus 3x. 8 and 3 is 11, that's 11x. Then 12 and minus 12 wipe out each other, don't it? So the answer is 11x over 12. That is the answer right here. But the 12 wipe out this minus 12. All right, that is it. But good. If this was a minus in here, suppose this was a minus. Instead, suppose this was a minus. Then the answer would have been, let's work it out, what the answer would have been. So I've been 8x minus 3x, that would be 5x. Then what is now? It will be 12 minus a negative 12. Minus will be a plus. See that? That will be 24. See that? Minus will be a plus. If this inside there was a negative instead of a plus. All right? So I was doing that to show you that was the case. But they gave us a plus, so that is it. All right, let's go. Next question says, write the following statements as an algebraic expression. The sum of a number, and we can call the number n or x or whatever we want. The sum of a number and its multiplicative inverse is 5 times the number. Sum means that you add them, right? So the sum of a number, let's call the number x. And it's a multiplicative inverse. The multiplicative inverse is the inverse of multiplication. Inverse of multiplication is 1 over x. Right? Inverse of multiplication is 1 over reciprocal. Is meaning equal. Is meaning equal. 5 times the number. 5x. That's what they have just said. But understand that? But understand that? The sum of a number means that you're adding a number, call that number x, and its multiplicative inverse. The multiplicative inverse of x is 1 over x. And that sum is meaning equal. 5 times the same number. 5x is 5 times the same number. That's a statement right here. But good? They don't need to add to solve it. Just write the statement. All right? Just write the statement. They ask you to solve it. Next question says, factorize this completely. That's the difference of 2 squares. That's a square, and that's a square. Because 36 is the same as 6 squared. This can be written as x squared minus 6 squared. Then we apply the rule for the difference of 2 squares. The difference of the numbers and the sum of the numbers. So it becomes x minus 6 times x plus 6. That's it. That's the answer right here. And factorize the difference of 2 squared. Remember, the rule for the difference of 2 squared is this. A squared minus b squared is equal to a minus b times a plus b. That's it. That's a factorize the difference of 2 squares. Must know these things, guys. All right? Know what you need to know. Factorize this one. Let's use the process. Let's go through the process again. We want to factorize a trinomial quadratic with 3 values, 3 terms, called a trinomial. You want to split this middle value. Split that 5x and turn it into 4 values. So you can factorize by part. Understand? All right? So the process, as we know it, to split this middle value is to first multiply the n coefficients, 2 and the minus 12. I can look at this and factorize, but let's go through the process. It's 2 times negative 12 is equal to negative 24. They want factors of negative 24 that add to the middle coefficient of positive 5. It's ABC method I use. So I multiply the A times the C a while ago. That's what this is. A times C. All right? And they want factors of the AC that gives you the B. Right? They want factors of negative 12 that add to 5. Let's sort to the factors down here. Now, since you want factors of a negative number, one factor will be positive and one factor will be negative. Let's say you don't see what the 2 numbers are right off the bat. What 2 factors of 12 are where the difference is 5? You can go until you find it. So the first 2 factors of 24 is 1 and 24. You have to make the larger one have the same sign as this. The larger one is 24, smaller one is 1. You have to use two numbers with 2 different signs. Why? Because you want the product to be negative. The product is negative, then one factor will be positive and one factor will be negative. May the larger one has the same sign as the number that you're trying to them for them to add to. When we add negative 1 and 24, you get in 23. You don't want 23, it's 5 you want. You go to the next 2 factors of 24, which is 2 and what? 12. The large one positive, the smaller one negative. But 12 minus 2 is 10. You don't want 10, you want 5. Next 2 factors is 3 and what? No, 24. Factor of 24, I'm talking. 3 and 8. 3 and 8. The large one positive, the smaller one negative. Now 8 minus 3 is 5. So yes, you have found it. It means they're going to split this 5x into minus 3x and 8x plus 8x. I can turn them around and write 8x minus 3x, same difference. Split the 5x into that. That's what this means. So I've now found we're going to split this 5x into. We're going to split it using these numbers. So this then becomes 2x squared, split the 5x into 8x minus 3x plus 8x minus 3x. That's what this middle term I split it into. Then I'm putting back this negative 12 minus 12. You want to factorize by parts next. So I can factorize in these two first. Highest common factor. Highest common factor in those two is 2x, right? So you factorize the 2x out of this. You're going to get an x. Out of this, you're going to get a plus 4. Divided by 2, you're going to get a plus 4. I always say I want the same thing in the bracket over here. So I tend to write by the same thing in the bracket first. X plus 4 in the bracket first. Then in between here now, you want to know what factor out of these two to give you this inside here. It has to be a plus or a minus value, not just a value. So you know what it should go in the bracket. So you can know it, for example, by dividing this negative 12 by this positive 4. That's a negative 3. Or you could divide this negative 3x by this x. Same way you take it, that's a negative 3. So negative 3 coming in inside here. If you're not sure, you can just expand this back. Negative 3 times this x is negative 3x. Negative 3 times this 4 is negative 12. So you know you factorize it good. Then what it is now is that this x minus 4 is the common factor, and they are connected with this 2x minus 3. And so this then becomes 2x minus 3 connecting x plus 4. And those are the two factors. What about that? All right? That's the practice it, guys. If you don't make no sense, we get these things wrong in the exam. But practice them. All right? Next question. Next question says, the formula for volume of a cylinder is this. V equals pi r squared h. It says make R the subject. So we have V equals pi r squared h. I want to leave this r alone by itself as the subject. You can transpose everything away from the r and leave the r by itself. All right? So the first thing we can do, you can get rid of the pi and the h. Divide them on this side. You divided them because they are being multiplied over here. The same as saying you divide both sides by pi h first. Shortcut is to say you divide them under this side. So anyway, you're taking b over pi h. So the pi come under here and the h come under here. That is now left to the r squared. And to leave the r by itself, we're going to have to square root both sides. Inverse of this square is square root. You're going to square root that side and square root that side as well. So that the square root cancel away the square. I left with the r alone. Right? So you're going to end up having r by itself now equal to the square root of b over pi h. But of course, them say make r the subject you want to put on the left side. So we're going to write i.e. That's it. The r is equal to the square root of b over pi times h. And that is. Very good? All right, next part now said, given that this thing equals that, work out the value of a and b. If this thing equals that, work out the value of a and b. Now, for me, the quickest way I think to do this is to actually expand this out and get it to look like this. When it looks like that, then I can see what the a and the b is. Expand out the right side. But understand that? Yeah? Let's expand out the right side. For me, that's the easiest way to do this. So I'm going to expand out this side. So I'm going to have x squared plus ax plus b is the same as this expanded out. Right? And then you're going to compare. So we expand this perfect square, guy. Remember, it's first term squared plus the product of 2, second term squared. So the first term squared is x squared. Then twice the product of 2 means that you multiply these two things first and then you double it. So multiply the x and the 2, we're going to get 2x. You double it to 4x. Then the second term squared, the 2 squared is a 4. That's what I've gotten from this bracket. Then I have to subtract this 3 now, minus 3. Let's simplify. It becomes x squared plus 4x. Then the 4 minus 3 is a plus 1. If you compare the values now, it means that this A is equal to this 4 and this B is equal to this 1. But see that? See it? We compare. See that? Right? Simple as that. They tell you that this is this. They just expand out the right side and compare the values. So you can draw the conclusion and say, therefore, the A is actually 4 and the B is actually 1. These are your answer. All right? Nice and easy. But good? All right. Yes, on this question done. Number 1. Use a calculator to do this. Huh? Turn on the AC. You need to move from under the fan. You can't turn on the AC. It's going to get very hot. It's going to get very hot. So you got the both of them. So sit down on the fan. Over there, so on the fan. You sit right under the fan. Lift the chair, lift the chair. The question says use a calculator, work this out, just put it in the calculator, please, exactly as it appears there. So the fraction, on top there's a mixed number first, which is 3.5. Then we are multiplying that by another mixed number. But I can see it. And then dividing that now by yet another mixed number, 4 and 1/5. Guys, the nice, nice, pull up on 9. And answer is this. Once you see the exact number, this is the answer right here. 1 and 7/8. 7/18. That's the answer. All right. Next part one, so to work this out. Use the calculator again. Use the calculator again. To type it in the calculator. 3 marks just stand this, 5.47 minus square root of a fraction. That's 0.1014 over 1.5. That's 5.21 equals 5.21. That's it. All right, then we'll come to this question now. This question says, table below shows the number of tickets sold for a bus tour. Some items in the table are missing. All right, let's read out what the table is showing. All right, so there's that. You have juvenile ticket, youth ticket, adult ticket, right? And the number of tickets sold here is 5, 14, and R. We don't know R. And then now, this is a cost per ticket, cost for one ticket. So one juvenile ticket, 5 of them is for $P. And this is the total cost. So it means then to get this value over here, we multiply these two. To get this value over here, multiply these two. All right? That's what does that mean in this table. And then to get the value over here again, you have to multiply again. The value that is missing here. All right? This is what it says. It says calculate the value of P. That's on this line. We know that 5 times P is equal to 130.5. What does that? 5 times P is equal to $130.50. So to find divide by the 130, divide by the 5. And do that with the calculator. How much? 26.1. I put dollar sign on it. The value of B. The cost of 1. You put dollar sign on it, right? Dollars. So it's how much you say? 26.1. I put dollar sign on it. 26.10. Money. I put the 10 is money. And what is the cost, you know? You have to make the thing realistic. It's money. All right? That's 26.1, him say. So this is 26.1. All right. Next part now is the value of Q. So the value of Q now is I multiply 14 times if I get Q, right? So Q is equal to 14 times the 4435. What are we going to? How much? 6 how much? 190. All right, I trust you. All right, that's that. Next part now says an adult ticket is twice the cost of a youth ticket. What's a youth ticket again? This. So the adult ticket is 2 times this. So right here, so becomes 2 times 4435, which is equal to 8870. But I can say that 2 times 8870. So right here, 8870. Calculate the value of R. So it becomes R times 8870 equals this amount. But I can say that. All right? So it becomes R times 8870 equals, what's that number now? This number is 2483.60. 2483.60. 2483.60. And I put the dollar sign on it because R is a number of tickets. That will get the value of R for ticket, right? 2483.60. So divide this out now. R equals 2483.60 over 8870. So in the total we have the answer. 2483.60 over, that is 88.70. That's how I get. Something is wrong. Oh, I didn't put this in right. I put 21. It's 24. 2483. 2483. Oh, 28. So you see, if you get a full answer, don't just accept it. You have to be smart. Right? So, no, the exact value we get. Huh? 28. There's 28 tickets. 28 tickets. 28 adult tickets. All right. So the bus company pays tax at 15% on each ticket. Calculate the tax paid for the bus company. So the total cost times 15%, right? Right? So we add up the cost of everything. Right? Add up the cost of everything. What was Q again? Q was 62.90, right? So right here, so it was 62.90. 62.90? No, 620.90. 620.90. So can I put the total down here, so, right? Total. Add up these and that's the total. We're charging tax on the total. So it's 130.5 plus 620.9 plus 2483.6. So the total here is 3235.00. 3235. Put in tax on that. All right. So put the information in the table. So we're working with this file now. We'll put it on the table. I'll put total right here. So the tax becomes 15% of that. So the tax equals 15% times that amount 3235. equals. So 15% of P2P5. And that tax is 485 and 25 cents. That is it. Very good. That's an easy question. Question done. All right. That paper done. Let's jump to June 2017 and get some work done. All right, let's jump to June 2017. June 2017. Where are you? June 2017. That's just really. Yeah, to the card. All right, June 2017. Let's go to the back of the paper and do a couple questions. Let's see if we can look at section 2, right? I don't have a thing to scroll this. I don't know. I see that scroll. All right. Let's get some practice on section 2. More math equals better. Let's go. Question says, matrices A and B are such that A is this and B is that one. Show by multiplication that AB is not equal to BA. Show by multiplication that AB is not equal to BA. Much marks to this? 2 marks. Now, as far as I'm concerned, if one value different, then they're not equal. So if I start working out AB first, which is 3254, and I multiply that by B, which is 403 negative 1. 3 negative 1. All right? I'm going to start the calculation and put this over to the left somewhere. Remember, we multiply matrices, we multiply the rows of the first matrix by the columns of the second matrix. And that's going to be equal to a big 2 by 2 matrix with 4 values. Or multiply them again. This first element is in the first row and the first column. So to get to multiply this first row by this first column is a different column. It's a different color for this part. All right? So multiplying this first row by this first column. Multiply a row by a column. First element in the row and the first element in the column. Second element in the row by the second element in the column. So it's first element times first element. Second element times second element. So it's 4 times 3 is 12. And 2 times 3 is 6. Now that's 18. Let me start work with the other product. The B times A beside it. B times A. Which now becomes 403 negative 1. That's the B. Times the A. Which is 3254. I'm going to start work it out. I'm going to start work it out again. I get a big 2 by 2 matrix. And again, I have to multiply the rows of the first matrix by the columns of the second matrix. And I say, okay, let me report this first value first right here, which is in the first row, first column. So to get it, we multiply this first row by this first column. First element times first element. Second element times second element. So then, it will be 4 times 3 and 0 times 5. Now the 4 times 3 is 12. And the 0 times 5 is 0. Already they are not equal. That is an 18 and not a 12. But I understand that. But to my mind, if you do this in the exam, you're supposed to get your marks. But you would have shown that they are not equal. See that? See that? Because the first element not the same. Because this is 18 and this is 12. And I would say AB is not equal to BA since 18 is not equal to 12. And I work out no more. And it's only 2 marks. Alright? But maybe you need to work out the whole of it. I don't want to do 2 full multiplication. Work out the 2 of them fully. I doubt it. So maybe at least you work out 1 of them fully. Right? So let's work out the first one fully. But once you start the second one and have value different, you know, say they're not the same. So let's work out this first one fully then. Let's work out the first one fully. So the value here now that we want is in the first row, second column. So to get it, we multiply this first row by the second column. Multiply them the same way again. First element in the row by the first element in the column. Second element in the row by the second element in the column. First element times first element. Second element times second element. So it's first element times first element. That's 3 times 0 is 0. Second element times second element. That's 2 times negative 1 is negative 2. So that is becoming negative 2 in the end, right? And this value down here is in the second row, first column. So to get it to multiply this second row by this first column. First element times first element. Second element times second element. First element times first element. Second element times second element. 5 times 4 is 20. 4 times 3 is 12. The last value out here is positioned in the second row and the second column. So to get it to multiply this second row by this second column, same thing again. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 0 is 0. 4 times negative 1 is negative 4. I'm just write what these are in the next line. Down here, I shift this down. Shift this over here. So this matrix would work out to be the end, working out fully, to be 18, negative 2, as is what, 32, negative 4. But once we work out the first value and I see it come different, I don't have to work out anymore. This value and this value are not the same. I don't have to go any further. Once one value different, the matrix is different. Here you know the one, a to the minus 1. That's the inverse of a. What is a again? A is the matrix 3, 2, 5, 4. One inverse of that matrix. Let's work it out in purple. So a to the minus 1 is 1 over the determinant of the a times the adjoint of the a, which becomes 1 over the determinant. Okay, the determinant again. First diagonal product minus second diagonal product. The first diagonal product right here is 3 times 4 is 12, minus the second diagonal product is 5 times 2 is 10. You multiply that now by the adjoint of the matrix. What do the adjoint? Interchange the elements on the first diagonal. Interchange them. So the 4 goes up here, the 3 goes down here. Switch them around. Then the elements on the second diagonal. Leave them where they are and change the sign. So this 2 becomes a negative 2. This 5 becomes a negative 5. Under here says just a 2, right? Let's put it in a blue. This works out to be a 2. That's what this works out to be. Blue, Mr. Shaw, blue. The determinant is 2. So you know, dividing each of those values by 2. So it becomes equal to 4 divided by 2 is 2. Negative 2 divided by 2 is negative 1. Negative 5 divided by 2 is negative 2.5. 3 divided by 2 is 1.5. And this is your a to the minus 1. Next part now says, write down the matrix represented by a times a to the minus 1. A times a to the minus 1 is I matrix. The body should know that. A times a to the minus 1 is the I matrix, which is 1, 0, 0, 1. 3 marks that. The product of a matrix and its inverse is the identity matrix for multiplication. 1, 0, 0, 1. That's the matrix that gives at the number 1. All right? Next question says, write a pair of simultaneous equation as a matrix equation, as a matrix equation. So you make sure that you have x value followed by a y value in the two equations, x value followed by a y value, which is fine. And it becomes a 2 by 2 matrix times a column matrix xy equals a column matrix with these values 1, 5. And the values inside here are the coefficients of the x and the y up here. So it's 3, 2 on the top line, 5, 4 on the bottom line. I must realize that this matrix is actually the matrix A that from before, up the top. That's all. 3, 2, 5, 4. See there? See a matrix 3, 2, 5, 4. So that's the matrix A. Right? And now they say write the solution. Write the solution as a product of two matrices. So we have this down here. And I want us now to write as a product of two matrices. So see it here now. The solution is xy now. So leave xy the subject, you take the A and bring it over here the inverse. That's what it is, remember. So the xy is going to be equal to A to the minus 1, A to the minus 1 times the 1, 5. So the matrix A, inverse comes in front here. The A is in front on this side, the inverse goes in front on the right side, and leave xy as the subject. Simple basic matrices transposition. And so the xy becomes equal to the inverse of the A that we just calculated at the top. We just worked out again. We just worked out a while ago. This is it. See here? Let's copy it down. It becomes this inverse matrix that we just worked out a while ago. A to the minus 1. Right here. Times the 1, 5. And then they ask us to solve it. And then ask us to solve it. So we need to solve it. Say just write it. Write the solution of the matrices equation. That's it. Of the matrix as the product of two matrices. That's it. The product of two matrices. That's what they want to say. They then ask to solve it. So let's leave it like that on your hands. But I go to that. This is the 8 to the minus 1 matrix that we calculated up top. That part is finished. Then we come to vectors down here. It says the position vector of the points P and Q relative to an origin O are these. That's OP and that's OQ. Respectively. So the diagram below shows PR is 3 times OP. So this side here, so it's 3 OP right here. Let's put on there. This is 3 OP. So it means that everything else now is 4 OP. OP plus 3 OP is 4 OP. So it means that OR is 4 OP, right? Let's write over here. So put that work it out. So OR becomes 4 times OP, which is 4 times this. So it really becomes 16, 12. 4 times 4 is 16. 4 times 3 is 12. That's what OR is. And it says QS, this QS is also 3 times OQ. So right here, so from Q to S is 3 times OQ. So again, OS then is 4 OQ. 1 OQ plus 3 OQ makes 4 OQ. That's what OS is. So OS is 4 OQ. 4 times this. Now 4 times 5 is 20. 4 times 0 is 0. So OS is equal to 20 0 line. We know those vectors now, you can work with them, right? Question says, must calculate the vector OS. Each year, just work out a while ago. You did so? So OS equals 4 times OQ is equal to 20, 0. 4 times this vector right here. Next vector I want is PQ. So to find PQ, we're going to do O times the last minus O times the first. OQ minus OP. O times the last minus O times the first. What is OQ again? OQ is 50, OP is 43. 50 minus 43. That becomes equal to 5 minus 4 is 1. 0 minus 3 is negative 3. 1 negative 3. That's the vector PQ. Then we want the vector RS. Same thing again. We're gonna use O times the last OS minus O times the first OR. What was OS again? 20, 0, don't it? And OR was, what did we get? 16, 12. OR was 16, 12 up here, so 16, 12. OR is 16, 12. So you're gonna get 20 minus 16 is 4. 0 minus 12 is negative 12. Then it says, state two geometric relationship between PQ and RS. What do we have? We have PQ is minus 1, 4. That's what we got. No, minus 1, no, it's 1 minus 3. They're gone. 1 minus 3. Where did I get this from? 1 minus 3. And then RS is this one. 4 minus 12. Now you can clearly see that this big one is 4 times the small one, don't it? But you can see that? Obvious, don't it? You multiply this by 4 for it to be equal to that, don't it? So you can write that RS is clearly 4 times PQ. But you can see that. So you want two relationships now. One, because one vector is a mode of the next, it means that they are parallel. They are parallel. So they want two relationships. One, RS is parallel to PQ. That's one relationship. The second relationship is how long one is more than the next. RS is 4 times as long as PQ. Or 4 times the length of PQ. You can even see it on the diagram. See there, RS, this vector R is 4 times the length of this. And then parallel. See? Those two vectors are parallel. And the RS is 4 times as long as the PQ. You're seeing it in the numbers down here, sir. But this is 4 times that. So they want two relationships. Tell them one that they're parallel. Second one, state how long one is more than the next. Second relationship. So you can write that RS is 4 times the length of PQ. Done. Two relations. One that the parallel, other one is how long one is more than the next. 4 times as long. All right? But good? All right, let's go. That was number 11. Let's go to number 10. Let's see where I'm finishing section 2. We'll call it that. Number 10. Number 10 says, PQ, R, and S are 4 points on the circumference of a circle shown below. Angle QRS is 58 degrees. Angle QRS right here says 58 degrees. That's the angle at the center and so on, right? It says, using geometric property of a circle to give reasons for each step in the answer, determine the measure of angle SPQ. Where is that now? SPQ is right here. SPQ, right here. So you must recognize that that's a cyclic quadrilateral, right? See that? The opposite angles are supplementary. Remember that? So the angle down here is 180 minus 58. So this angle becomes 180 degrees minus 58 degrees. How much is that? What is that? 122? So this angle down here is 122 degrees. And that's because opposite angles are cyclic, quadrilateral, are supplementary. Opposite angles in a cyclic, quadrilateral are supplementary. Supplementary means that they add to 180 degrees. All right? They add to 180 degrees. That's what supplementary means. All right, next question. Angle OQS. Angle OQS. OQS. That's right here. This angle one. All right. So watch this now. To find this angle right here, we have to recognize first that it is equal to this one, don't it? All right? Then now, we have to also recognize now that this angle is 2 times this one. But I say that? Angle at center is twice. So once you find this one, you can use the isosceles triangle to find these two, which will be equal. But understand that. So we tell the examiner first that this one at the center right here first is 2 times. 2 times. So when I say this angle right here is 2 times 58 degrees, which is 116 degrees, right? Good. And then this angle inside here now becomes 180 minus 116 divided by 2. What do you agree with that? Huh? 180 minus 116 is what the two of these add to. And you divide by 2 because you want only one of them. So it becomes 180 minus 116 divided by 2. What are we working out to? 42? You sure? Just so you know, it's 90. One again. Somebody worked out for me. One again. How much? 32 degrees, right? So I'm going to tell you that the angle center, this one, because angle center is twice angle circumference. This one is its angle SOQ. Let me write it now. So let me copy this down. Angle SOQ. And then the angle that we want right here now is angle OQS. Let's copy these down now. Put it down here, so. Oh, man. All right, so for this one, you use that angle center as well as angle circumference, right? This one, angle at center is twice angle at circumference. That's that one. And then this one, total angle in isosceles triangle is 180 degrees. Total angle in the isosceles triangle is 180 degrees. All right, that's how we get that angle OQS. And down here now, the different question. All right, This now is bearings. Question says, it says a ship leaves port A, that's here, and says 52 kilometers on a bearing of 044 degrees to port B, that's here, so. And a bearing of 044 degrees. So that bearing angle, let me extend this line. So that bearing angle is this one, it's on in red. That bearing is 044 degrees. And then the distance is 52 kilometers right here. Remember, bearing is a direction, it's not an angle clockwise from the north line, from the north direction. So that is the bearing angle that they told us about. He said the ship then changes course to Port C, 72 kilometers away. That's right here, 72 kilometers away, on a bearing of 105 degrees. So from here to here, the direction is 105 degrees in terms of bearings. So it means then that this angle down here, so now, is 105 degrees. Clockwise again from the north direction to the direction that you want. That distance is 72 kilometers. 72 kilometers that distance. All right. I think it was. All right. Question said now, determine angle ABC. That's angle inside here. This angle right here, that one. ABC. So a nice quick way to find this angle to split it. Extend this line down. They want to say, okay, let me use the purple. We're going to have Z angle over this end. So this angle and this angle is the same. That's 44 degrees like this. Z angles are equal, so you have 44 degrees over here. And then total angle straight line is 180 on this side. So this angle there so becomes 180 minus 105 right here. Is now 180 minus 105. But I get that because total angle straight line is 180. So 180 minus 105 is about 75. So the total angle across here that I want is sum of those two. Black. That total angle is red. Become the sum of those two. 44 plus 75 is how much? 119 degrees. So this angle is 119 degrees. So tell the examiner how we get it is equal to 44 degrees plus 75 degrees, and on the diagram, which is 119 degrees. 119 degrees. All right. Next, they want us to calculate the nearest kilometer, the distance AC. Distance AC. Gonna work cosine rule in the triangle now, but I can say that to get the distance AC. See there? Because we now have two sides and an angle between them. So it's cosine rule for AC. Let's just do it on the screen right here and we'll copy it down. So cosine rule for AC. Cosine rule for AC. They start by saying AC squared equals this side squared plus this side squared. 52 squared plus 72 squared minus twice the product of the two sides. 2 times the 52 times the 72 times the cosine of the angle between them, which is the 119 degrees. But again, as always, instead of leaving the square here, we can square out this side and put the square, and then square out all of this side over here. And then do just one calculation to get what the AC is in one calculation. Very good? Let's do it here, sir. What do you think, God? All right, so it becomes equal to the square root of 52 squared plus 72 squared minus 2 times 52 times 72 times the cosine of 119. That's 107. Did they want the nearest kilometer? The nearest kilometer, he said, oh, put in a decimal. So it's going to put 107 kilometers. 107 kilometers. So I'm going to copy this down. Paste it down here. Come on, come on. All right, that is that. Next part now says, show that the bearing of A from C to the nearest degree is 260 degrees. The bearing of A from C, A from C. Remember, if you want the bearing of A from C, I will note the from position. So it's from C to A, the direction from C to A you want, right? So you tend to do the bearing at the from position, C to A. You want C down to A you want, bearing down here. So you want the bearing of this direction, C to A. All right, at the from position. So we want to show the bearing on the diagram. We don't like the angle inside the triangle, we play a part in the calculation here. We play a part in the calculation, C to A. All right, you can also do it down here if you want to, you know, C to A. Because the same direction that's in it. C to A. So if you find this one, it will be this plus the 180. If you want to do it that way, because the same direction. Realize that? Look what I'm saying. The direction from C to A is this direction, C to A. This direction down here. You don't have to work out the bearing there, sir. You can actually work it out down here because this is the same direction, C to A. So the bearing of this direction would be this angle now that I'm going to draw. It would be this angle same way. All of this angle. So to get that angle, we could work out the one inside here instead. Add it to the 44 and then add 180 to it and get the bearing. But understand that? You can do it that way. All right? But we can also work it out up here. In fact, I'm going to do it both ways and so. Right? Just make sure you understand. So I understand that bearing is a direction. So I'm going to call this one down here, so beta. I'm going to call it alpha. Let's call this one beta. I'm going to find this one and show that I could have worked it down here as well. This angle inside, I'm going to call it beta. I'm going to call this one alpha. So if you're working the bearing up here, let me extend it now and bit. Then we'll be talking about this angle that we want. That angle we want. All right. Now to find that angle, what we could do is work out the one inside here. But these two angles are up to 180. So we could find this angle here first. Let's do it. This angle right here, so. It's co-interior with this one, right? Or if you want, you can work the Z. See the Z here. So this angle here, so it's 75. But these two angles are up to 180. Co-interior angles. All right? So anyway, you take it, this angle inside is 75 degrees. This angle across here says 75 degrees. And then now, that blue angle that we want, which is the bearing angle, will be 360 minus the 75 and minus the alpha. So anyway, take it, you're gonna have to find the alpha. But understand that the blue bearing angle that we want will become 360 minus the 75 and also minus the alpha. So we have to find the alpha, right? So make a note of it. So this bearing angle that we want, theta, will be 360 degrees minus 75 degrees minus alpha. How are we going to find the alpha? We're going to use to find the alpha. Sine rule. Yes, because we have this angle and this side. We know this side. No, this side was what? What did you get for it again? What did we get for the side? We got 107, yes. 107. Good. So this side we know is 107 kilometers. All right. So we're gonna use sine rule. This side and this angle across each other. With this side and this angle across each other in the sine rule. That will be sine rule for alpha. All right. Let me do it and then copy it. So we're gonna use sine rule. Let's do the calculation here. So the bearing of that I want, bearing of A from C is theta, which is 360 degrees minus 75 degrees minus alpha. And I'm going to use sine rule for the alpha right here. Sine rule for the alpha. They're going to be sine of alpha over the side opposite the alpha. Side opposite the alpha is the 52 equals sine of the angle that you know, which is the 119. Over the side opposite the 119, which is 107. And then to find the alpha, I'm going to take the 52 and multiply it up here and then take the inverse sine x. So the alpha is the same calculation all the time, guys. Alpha is going to be sine to the minus 1 of 52 times the sine of the 119 divided by the 107. Same calculation all the time. Put that in the calculator. So sine to the minus 1 of a fraction, and it's 52 times the sine of 119 over 107. That's 25.1. Alpha equals 25.1 degrees. Of course, this beer can just call it 25. I want the nearest whole number, right? 25 degrees. Then do the calculation up here, so now, right? You're gonna get the 260 that they said. But then it's gonna be theta then equals 360 minus 75 and minus 25. So I can subtract in 100. 75 and 25 is 100. So theta become 260 degrees. That's one way to do it, right? Let me do it now on the other end and show it. Let me do it on this end and show that we're gonna get the same answer. Let me copy this stuff. That's one way to do it. Other way to do it, I calculate again now using this point down here. So we do calculate it down here, so right? This is still theta. The same angle where I work out, this angle theta. But this time it will be 44 plus the beta inside, which you don't know. Special. Plus 180 degrees. That's the other way to find it. And we have to find the beta inside here, sine rule again. So if we're using sine rule again on the same tip, but because we know this angle is up, let me use the sine rule and do it again. So it will be this. It will be that the theta equals 44 degrees plus beta plus 180. I'm going to put the 180 in front. Plus the beta. And I want to use sine rule for the beta now. See it here? Sine rule. So it's going to be sine of beta over the side opposite the beta is the 72 equals sine of the angle that you know, which is the 119, over the side opposite the 119 is the 107. Same kind of calculation. Multiply by 72 and then take the inverse sine, So the beta would be sine to the -1 of the 72 multiplied up here, and the sine of the 119 degrees divided by the 107. And put this in the calculator now. So instead of that to be 72 in the calculator. 72 times. And that would be 36 degrees. So beta would be 36 degrees. So the 36 degrees back up here, so now we're going to get the same angle that we got before for the theta. So the theta would be 44 degrees plus 180 degrees plus 36 degrees. If I add up all of these, 44 plus 180 plus 36. So you get the same 260 degrees. So you do have to measure the front position. You just want to get the bearing of the direction. No, bearing of the direction. You can work out anywhere on the paper. Once you can get the bearing of a direction, you're good to go. So you see, I work out the bearing of this direction C to A, I worked out up here, and also worked out down here, and it's the same angle that we get. Bearing is not just, bearing is the angle of a direction. It's a direction. Remember that, the direction. All right, time is it? 7:06. Can do one more for call it a day. And do one more. That finishes that question. Let's do one more question on the way. And then we'll call it. I do a 7:06 now. All right. Let's do the number. Let's do the number 9. Finish on section 2. And we'll call it. All right. This question says, the velocity time graph below shows the motion of a cyclist over a period of 40 seconds. You could do this question that I did. It says calculate the gradient OA. Remember, gradient on a velocity time graph is acceleration, right? Gradient on a velocity time graph is acceleration. So ask for the gradient, is with the acceleration they ask for. The gradient is rise over run. It just rise over the run. And the rise is 10 over the run is 25. 10 over 25 is the one. Huh? 0.4. So it's 0.4, you have to write meters per second squared. Okay, you know it's acceleration. So you have to write meters per second squared. Okay, you know it's acceleration. Alright? The gradient is acceleration. So you have to write the unit, meters per second squared. Why is it meters per second squared? Because the speed is in meters per second. Is in meters per second. So meters over second. And the time is in second as well. So that's over second. See that? So you have meters over second divided by second. It becomes meters over second squared. Work this out. Right? That's why it becomes meters over second squared, which is what this is. Meters per second squared. Alright? Meters per second squared. Alright. Then we want the gradient of AB. The gradient of AB is clearly zero, right? Zero. That don't need a calculation. The horizontal line. Gradient of AB is equal to 0 meters per second squared. It's 0. And the car is going at a constant speed up here. So there's no acceleration up here. Horizontal line, the gradient is 0. There's no rise. Alright? Next part now says, complete the following statement. The cyclist started from rest where the velocity was. What's the velocity at rest? 0. 0 meters per second. And steadily increases velocity by how much meters per second? 0.4 meters per second each second. Good, that's acceleration. It increases velocity by 0.4 meters per second every second per second. That's acceleration. 0.4 meters per second per second per second, each second. In the first 25 seconds, that's what happened. It says during the next 15 seconds, the velocity remains constant. That is, the acceleration was 0 meters per second squared. On the top here, so acceleration of here says 0 meters per second squared. All right, that is that. So determine the average speed of a cycle over the 40 seconds. That's total distance over the total time, right? So it's your average speed equal total distance over total time. Total distance is total area. Remember now it's area. Distance is area. Now distance on a speed time graph, distance is area under the graph. Now what is that area equal to? That trapezium. See that trapezium again. You want the area of this thing. So it's half the sum of the parallel side. You want this area inside here. So this area you want. That's trapezium. So the parallel sides in here. These are the parallel sides. This side and this side. Now how long is this? This is 15 seconds, right? Up here says 15. And then it's 40. The distance between the parallel sides here, so it's 10. 10. All right? So 15, 40, and 10 are the numbers you're working with. 15, 40, and 10. Parallel sides. So this becomes half 15 and the 40. Half some of the parallel sides. The distance between them is 10. And the total time is how much? 40. Total time is 40. So this is the area that I worked with up here now. Half the sum of the parallel sides, then the distance between the parallel sides. And then I'm dividing that now by total time, which is 40. Wrote that out, I get the answer. This is how much? 55. So it's half of 55. Half of this 10 is 5. So it becomes 5 times 55 divided by 40. 6.85. 5 times 65. That becomes 6.875 meters per second. That is it. Meters per second. But it is half of this 10 is the 5. And then the 45, 15 and the 40 is 55 and divided by 40. That's it. Question I don't need to know when I'm done. Wanna go ahead. Next question said, answer the pair of simultaneous equations without solving, show that this point is a solution to the pair of equations. We can show that this is a solution to the point of equations. All you have to do is take the values and substitute it in there in both of them, and it will work on both of them. If the point satisfies both equations, then it is a point on both equations. All right? So just put the 1, 2 in both of them and it works on both of them. So you're going to put 1, 2 into x squared plus 2x y equals 5, and you test it. So it becomes 1 squared plus 2 times 1 times 2 is equal to 5 for true, don't it? Because it's a 1 plus 4 is equal to 5. So that is true, right? And you test on the second one. 1, 2, put that in the equation, is x plus y equals 3. That's 1 plus 2 equals 3, which is also true. Therefore, yeah, the point is a point of intersection. It satisfies both equations. And that's all you have to do. Right? So without solving, so you test the point in the two equations and it works in the two equations. We put the values in the two equations. It says now solve the pair of simultaneous equation to find the other solution. Solve them. So we're solving this line and this curve simultaneously. All right? So we have x squared plus 2xy equals 5. And we have x plus y equals 3. How we solve simultaneously line and a curve again? There are multiple ways to do it, but I said the safe way to do it is use substitution. So we can make the line of a y as a subject, so we can substitute it into the curve. So for this equation, you can transpose it and make y the subject. So y equals 3 minus x. I'm going to substitute the 3 minus x into the curve equation for the y right here. For the y is the same on the line and the curve, the points of intersection. So that's how we substitute the line with the curve. So sub for y, the line into the curve. You see this in September. This is one of the first topic that we did. Simultaneous equation, we did quadratics. Simultaneous equation leading to a quadratic equation. That's how we say we're going to do it. Substitute the line to the curve. And the equation is going to become x squared right here plus 2x right here times the y, which is 3 minus x, equals 5. And we have this equation to solve, put it in the standard form and solve it. So you get x squared plus, expand this now. 2x times 3 is 6x. 2x times minus x is minus x squared, minus 2x squared. That's equal to 5. And this x squared and minus 2x squared is minus x squared plus 6x equals 5. I want my square term to be positive, so I'm going to transpose everything over onto this side. I'm going to get 0 equals, this goes over and becomes an x squared. This goes over and becomes a minus 6x plus 5 equals 0. So I can put equals 0 here as well. It's all equal to 0. And then we're factorizing that. Factorize this. It's easy to factorize. No space we have. I'm going to factorize this now. Factor of 5 with the sum is 6 is 1 and 5. So it's x, 1 and 5. Signs are the same. They are both negative. So this factor giving us x equals 1. This factor giving us x equals 5. Remember we have x equal 1 already at one point. Where is it? See there, x equal 1 already at one point. So this is for the other point. This x equals 5 is for the other point that they told us about. And this is what I want. I already know that this one going to give us x equals 2. No, that x, y equals 2. Can we substitute them in this line equation? So we're going to sub into y equals 3 minus x. Sorry. You put the 1 in there, you're going to get the 2, which you know already. So to get the y value for this one, I'm going to plug the 5 in there. So the y value for this one is that y equals 3 minus 5. Where this graph comes from. So y equals minus 2. So the other point is 5, negative 2. This becomes the other point. That's it. Woo. Cough is contagious. All right, sorry about that, guys. But that's the other point. This was the first point, right? So the first point that they gave us. This is not the other point. 5, negative 2. So that's the answer. All right, guys, let's stop it there. See you all tomorrow as well. Oh, Wednesday. You're supposed to come online Wednesday. You guys coming online Wednesday. All right, bye, everybody. You guys coming online Wednesday.